Okay, so in this video, we'll do section 9.8, which is functions in SQL. And for that, we'll use this database as an example. It's the car showroom database. Um, all right, so let's create this database first. So here we have 4 tables. They have underlined, which is the primary key. And let's create the inventory table first. Now, they are also given rows for each table, so we can get an idea of what could be the data type for each. The inventory table, the car ID is something like this. So it's a character of 4. And car name could be like Desire, Bellingham, so on. We can then have it as varchar of say 15 or something like that. And the price is like, so I'm going to show you, you can say it as numeric of say 8 comma 2. So it will take 8 decimal values. 8 comma 2 means 2 decimal point values after the decimal point and 6 before that. So 8 comma 2, that's what it means. And the model is like this. So you can again label it as voucher of say some 15. Year of manufacture, like you can treat it as an integer if you want to. And then the fuel type is again like voucher of say 15 or something like that. So let's do it like this. So create table inventory. So let's create the database first. So create database car show, something like that. Then use car show. Okay, so I got inside that, so you can create all the tables. So create table inventory. We create the primary keys right away. So the unique values probably could be only the car ID because that's where you can have for each car. Because the car name cannot be unique, the price cannot be unique, model cannot be unique, year of manufacture, no. So car ID is the unique one. So car ID, it's a character of 4. You take exactly 4 characters and you can make it as a primary key. Then the car name is say varchar of 15 and it cannot be null, so you can make it not null. Then the price, as I said, is numeric of 8 comma 2. So 8 comma 2 means totally 8 digits and 2 digits after the decimal point. So 8 minus 2, 6 digits before the decimal point, like this. And it also cannot be not null. Then model is say varchar of some 15, and it cannot be not null also. And year manufacture. So year of manufacture, you can make it as int. And there's no need to specify null or not. Then fuel type, say varchar of 15, and let's say it is not null. So close it with the closing parenthesis and semicolon. And the second table is customer, where you have customer ID, customer name, customer address, phone, and email address. And again, among these attributes, customer ID could be the only unique thing. So we'll make that as the primary key. Now, phone number is an alternate key. So let's see what they have underlined. I think it should be customer ID because I don't think phone number is anywhere else. So we cannot make that as the primary key. Okay. Let's say you can say that's an alternate key because that's also going to be unique for each customer. Okay, so create table customer. Customer ID is again 5 characters. Always, so it's character of 5. Can make it as primary key. Customer name, varchar of say 30, not null. Customer address, varchar of say 40. Then phone number, it's a character because I'm not going to do any math with it. It's exactly 10 characters, so character of 10. You can make it unique if you want. And then email. Now, email is also going to be unique because no two customers can have the same email address. So let's make it varchar of say some 30 and also unique. Um, okay. All right. The next table is sale. So it's like what cars have got sold. So for each sale, you'll have an invoice number that is supposed to be unique. And two invoices can have the same car ID because two or more people can buy the same car model. So car ID cannot be unique, customer ID cannot be unique as well because the same customer can buy two or more cars with different invoices. Sale date cannot be unique. Payment mode definitely not unique. Employee ID, each salesperson can make two or more invoices. Sale price not unique. Okay, good. So let's go with sale. Create table sale invoice number. It's like 6 characters. So char of 6 primary key. Car ID char of 4. Not null. Customer ID char of 5. Not null. Sale date is a date data type. Then payment mode is var char of say 20. Then employee ID, the employee who sold it. This is an employee table which will create next. It's 4 characters. So character of 4, char of 4. Not null we can say. Then sale price is again numeric of 8, 2. Okay. That's for the employee table. So that's 4 characters. So create table employee. Employee ID is character of star of 4, primary key. Employee name, varchar of say some 20, not null. Date of birth, it's a date data type. Date of joining is also date data type. Designation is say varchar of 20. Salary is as of here it's given as int. We can make it int. And if you want, we can make it not null. Each person has to have a salary. Nobody's working for free. Let's see also. Oh, I put a comma after the int. Okay, we have to redo that. We cannot have comma after the int here. Okay, create table employee. Employee ID is char of 4, primary key. Employee name is char of 20, not null. Date of birth, the date. Date of joining is a date. Designation is char of 20. And then salary is int and not null. Okay, no space, no comma in the within the same attribute details. Okay. All right. So I created all the four tables. So now let's set the primary key foreign key relationship. The inventory has car ID as a primary key. Employee has employee ID as a primary key. Customer has customer ID as a primary key. The sale, these three attributes will be the foreign key for the corresponding primary keys here. So we have to now set the foreign keys. You already created the primary keys. The invoice number is the primary key for the invoice for the sale, but you have to set the foreign key relationship. So let's do that. Um, let's first do for car ID. So using the alter command, alter table sale, add foreign key of car ID references inventory car ID, and then alter table sale and foreign key of customer ID references customer ID, and similarly here alter table sale and foreign key MID references employee MID. Okay. So we'll have to first fill up these three tables, which are like inventory, customer, and employee, because they have the primary keys. So then only you can fill the sale table because they have the foreign keys. So the foreign keys can take values on these, which are taken by corresponding primary keys in this references table, reference to table, you can say. Okay, so let's fill up inventory. So it should be clear. So in which order you should fill up the tables. So we should fill up tables first primarily that doesn't have any foreign key. So when you're filling up a table which has a foreign key, make sure the corresponding reference to table with the primary key is already filled, because your foreign key values can be only among those taken by the corresponding primary key. For example, the car ID in the sale table can only come from the car ID values in the inventory, not something else. Similarly, the customer ID values in the sale table can only come from the customer ID values in the customer table, nothing else, and so on. Okay, so let's insert into inventory. I'm going to fill all of them, so I don't need to tell the column names. If I'm going to fill only particular columns, I need to pass those column names and then values of like that. Here, I'm not doing that. We'll pass the column names for the table. So for car ID, I say D001 within double quotes because it's a character. So all strings, character or varchar, you have to pass it in double quotes. Desire, then price 582613, model LXI, manufacturer, put as int. So let's just do it like this. Then fuel type is a character, so let's do it like this. One row added, so let's add the second row. So it is also desire. Price is 630.73 112. It is EXI model 2018. It's also petrol. Then it is B001 Baleno. The first character corresponds to the model name also. Then 567031. And that is Sigma 1.2 2019 petrol. B002, Valino 647858, Delta 1.2, 2018, also petrol, and E001, Eco, it is 355205, 5 STR is model name, 2017, it's a CNG, then E002, Eco 654914, ARE, and 2017 is also a CNG, and S001, then price is 514000, LXI 2017, petrol, VXI 2018 petrol. Okay, let's do customer. So insert into customer. So second way is write all the column names. Now here you can miss any column names and you don't need to pass corresponding value. Okay, but here I'm going to again pass all the column names, values, but still I'm writing all the column names. So this is all the column names that we use to create the tables. So I'm using them the same thing. Email, then values. So column names will accompany the table name within parentheses like this. Then the values. Customer ID is a character, 5 characters. C0001. The customer name is Amit Saha. Customer address is L10. Let's follow the same thing here. Phone number. I think I passed as character. So 456 458 7852. Then Amit Saha2@gmail.com. Pretty fine. So let's add the second customer information. 002 Renuma J12 SAKE, and 55276888761. Renuma@hotmail.com. And the third customer, Charvi Nayar, then 9 FF, and it's 681163545. This Charvi 123@yahoo.com. And the last one is 04 Gurpreet A10 SF for you. And it has 3511056 GUR. Okay. All right, so let's create the employee table. Then we're going to create the sale, insert the sale table. Okay, so I'm going to just because I already have it, so duplicates not okay. Let's just insert into using the values. Insert into employee values E001, employee name as the shield. Date of birth is 1994, 0710. Date of joining is 1994, right? Date of joining is 2017, 12/12. Designation is salesman and salary is salesman is one designation, yes. And second employee salary is this. Third employee and 75/08/30. Then this is 1999/01/08. And then 20,000. Um, 1989 06 06 2010 12/02 5. Um, Let's now do the save. Insert into save values I 4 zeros 1 E 1. See, all these are the primary keys in the other table. So you have to take only those values, nothing else outside. Okay. Date is also within double quote 2019 01 24. And then all this credit card. And same price. That's 0 online. Three nine zero three two. And let's see. 1919, go on, 25, beautiful. It's beautiful. It's 2024. Okay, so I've inserted all the records in all the tables. Let's doing things. Now, one thing we could do is, let's do in the order they're doing your book. So they're using, okay, before we get into functions on this table, let the tables be there, but let me show you, we can also do some simple math without involving any tables. So for example, I want to find 2 to the power 3. So select power of 2 comma 3, just like this, will give you the answer. 2 to the power 3 is 8. Okay, so select and then the function name, power. Now, let's see, then if you want to round things, let's see some interesting things. 56.34, you have specified to what precision you're rounding it to. So if you put 1, it will be 56.3. If you put 0, it will round 56.34 to, it will truncate basically because the 0.3 is less than 5, so it's 56. Instead, if it is 56.64, comma 0, it will be 57, versus rounding to the next largest integer. Fine so far. Now, if it is say 56.3464, doesn't matter. If I put -1, it will go to the left of the decimal point and see what value is that. It is 6. So it will round that integer to the next largest, what do you call, the 10th digit. So it will be 60. But on the other hand, if it was a 53.64 comma -1, it will round it to the left side because that 3 is less than 5, like this. It will be 50. So if I make it 5, it will be 60. Okay, that's something it's good to know. Let's do one more. So if it is 155.64 commas a -2, this 5 is greater than equal to 5, so it will round it to 200. On the other hand, if it is 145.64 comma -2, it will be 100. So these are good candidate questions for 1 mark questions. Then mod will give the reminders. Select mod of say 45 comma 11 is going to be 1, and 45 comma 12 is going to be 9, and so on. That's the reminder. So now let's start using the string functions. So you can say uppercase of Natarajan, it will be all uppercase. Then lowercase similarly will be that. Now the mid is an important function. Select mid of, say, Natarajan. And let's say, I think mid will take, okay, they have math functions first. Okay, let's first just do mid and go back. Mid will take the position and n. Okay, so that means, say again, the counting starts from indexing from 1. So from index 3, position 3, you want say 4 characters. So 1, 2, 3, then from there 4 characters, I think it'll be Tara, T-A-R-A. Okay, so that's same as taking substring. Okay, mid is same as substring. Select substring. It could be something like substring like this or str, both will give the same result. So again, Natarajan, comma 3, comma 4 will give you the same TRA. So the string name, then the starting position, and then from that position, how many characters. Okay, so we'll come back to the string functions later. We'll apply now the math functions on the table. So we want calculate GST as 12% of price and display the result after rounding it off to 1 decimal place. So the sale inventory is a table we have to work on. Okay. So select start from inventory. So we want to find the GST to be 12% of the price and print as with 1 decimal precision. So something like this. So let's do. So select 12%, so 0.12 times price. And you can display that as GST if you want from inventory. So that will print GST 68043. Now we want to round it to 1 decimal precision. So let's do that. So round off. So whatever it is, round to 1 decimal precision. So you can round it like that. So it will be like this. So it's not printing here the same order, but you can see the numbers there. 69913 is there, 80773 is there, 68043 is there. I'm not sure why it's doing that. That's fine. Okay. Let's print the commission. Okay, so they want to add a new column, which will complete that, final price to be the sum of the price and 12% of the GST. So you want to add a new column means we have to use the alter table command. So select start from inventory. So alter table inventory, add a new column which is final price. There is also numeric of 8, 2. Okay. Now we have to use the update inventory, no table, just update the table name. Set final price equals 12% of that is GST. So we can say it's 1.12 times price because price value plus 0.12 times price will be 1.12 times price. So we can right away do it like this. So if you select start from inventory, it will display the final price as well. Okay. Now let's do this activity thing. Let's where the invoice number is. So let's go to sale. Okay, so let's just say the commission person gets by selling a car is say 10% of the sale price. Okay, so you can do a similar thing. Select 0.10 times sale price displayed as commission if you want to. It's just for our understanding. You can just say from sale, it will just print with this caption like 0.10 times sale price. To avoid that such kind of caption, you can say as something. So select 0.10 times sale price as commission from sale. It will now print as commission. And you can round it to 2 decimal places, as they say. Round to 2 decimal precision. Okay. Now display the sale details where payment mode is by credit card. So select start from sale. So the payment mode has to be credit card. Okay, so select start from sale where payment mode equals. Now, since it's a character, let's try if you're passing it exactly like this, it should be fine. It will print all the credit card sales, but you can also do it like this, like. So somebody might have put a blank space before typing the C and after typing the D here. So you can also do it like this. It should be still be able to give you. You have to use a like in that case, the like keyword. Okay. Now, let's get into something else. Calculate and display the amount to be paid each month in multiples of 1,000, which is to be calculated after dividing the final price of the car into 10 installments. So this is like the EMI thing. So let's go back. So let's start from inventory. We got the final price, right? Okay, so we need to first find, divide this final price into 10 installment. So select final price divided by 10 from inventory. These are the things. So we need to multiply multiples of 1,000. So I would keep it simple, multiples of 1,000. So you can pay up to 63,500. Again, 72,000. Let's see how they do it. It's a little roundabout calculation, you probably don't need it. May not be at the board level, PUC level, it may be at the CBSE level. I was trying my best, but it's kind of difficult to understand how they calculate the EMI here. Okay. So what we can do is this. We can round this. Um, let's just do it like that. Okay. I tried. It's difficult calculation. I don't know how they do this. Well, we can type that formula if you want to, but it doesn't. I tried in ChatGPT. Doesn't say. It said this is not the way EMI is calculated. EMI means equal monthly installment. It's calculated based on interest, but they don't specify the interest rate here. So we can do final price divided by 10. So every month, this is a final price you have to pay if there's no interest on it. If there is interest, we have to do some interest calculation. Okay. Um, okay, let's do the next one. Let us now add a new column commission to the sale table. The column commission should have a total of length of 7, which 2 decimal places to be there. So that is like numeric of 7, 2. All right, so let's say select star from sale. Right now there's no commission attribute. So alter table sale, add commission as the column. It is numeric of 7, 2. Yeah, so numeric of 7, 2 should be fine. Okay. Now, let us now calculate commission for the agent as 12% of sale price. Insert the values to a new by. Insert the values to the newly added column commission and then display a record where commission greater than 3,000. Very good. So update sale set commission equals 0.12 times sale price. Okay, so this is what it is. Select start from sale. So now we want to display those records for which uh, commission was greater than 73,000. These are the 3 records. Display invoice number, sale price, commission such that commission level is rounded off to 0. Okay, so select invoice number, only 3 attributes. Select invoice number, sale price, round commission, comma 1. Rounded off to 0. I think you can say, let's print commission and then what happens if I round it? Rounded off to 0. Rounded off to 0 would be just like this. Sale. Okay, so this is 73590. This is what rounding off 0 means. Then 708,439, 72480, 79198, 44317, 74426. Rounding off to 0 means just rounding by considering what is the value after the decimal point. Okay. Now let's use the string functions. Um, um, so mid substring length of a string, we know what it is. Now left of string comma n. So if you say left of again Natarajan, and 4. So from the left, it will print 4 characters. So Nata. Similarly, you can say from the right, 4 characters. It will print AJAN. Now it will print the first occurrence of a substring if you want. Select in str. Let's say I want to see the first occurrence of A, for example. A itself, just one character, the substring. It will print then 2. Now I want to print the first occurrence of, say, anything else is repeating. No, let's then make it little difficult. Say this one, AL is going to be 2 again. AY is going to be 1, 2, 3, 4. So for the 4th character, you have AY. So it's AY there. Now L trim, it will trim all the blank spaces at the left. So if I have some blank spaces, then say language or something, it will trim all the black spaces and it will print the value. If you do R trim, it will trim all the right blank spaces, but the left blank spaces will be still there. So you see, this is the left blank spaces are still there. Then trim, I think, will print both left and right. Okay, so let's apply them on the tables. Display customer name in lowercase and customer email in uppercase from table customer. Okay. Select star from customer. The customer name in lowercase, email address in uppercase. Just those 2 attributes. The lower of customer name, upper of email from customer. Okay. Now let's look at this one. Display employee name in the last 2 characters of his EMP-ID. So select star from employee. Okay. So it's a character, employee name, and the last 2 characters of the employee ID, right? Okay. Select EMP name. Now there is a right function we can use to print things from the right. So select employee name. Actually, I would print employee ID first, but it's okay. This order they are employee name. Now write EMPID, comma 2, the last 2 characters from the employee ID. And employee ID is a string. So if you put right of employee EMPID, comma 2, it will print the last 2 characters from the EMPID from employee. It will print like that. Okay, display the designation of employee and the position of character E in the designation if present. Okay, select designation in the position. So in str of designation, character E from employee. Okay, so E is the 4th character, second character, and so on. Okay. Now, can you count the E? I'm not sure. Let's try. Count. No, we cannot count the number of occurrences of E. No. Okay. All right. So select star from employee. So let's order the distinct designation names in the employee table. So you can say select distinct designation within a parenthesis from employee. It will print these 3 designations. Okay, these are the 3 unique values there. It's not a string function, but it's already, I think you saw, but it's good to use it here. Okay, so display the length of email And the part of the email from the email ID before the at character, don't want the at character. So select starts from, I think it's the customer, yeah. So the length of the email thing, so select length of email, and we want to get just those characters before that. So first you have to know where the at appears, that is instr function. So instr of email comma this at, and we want to get everything to the left of that. So from the beginning up to that -1, because we don't want the at. So you can then say left of email comma everything, so that this will give you the position of the at. -1 will give you the position of the character before the at. So you want from the left the email attribute everything up to that position to the left of at. So this will give you that information. Okay, so everything before the at. Now, if you want the again, let's say select from employee or customer. You have Gmail, Hotmail, and Yahoo as the email services here for the email address. So if you want that name, let's filter out the .com first. Select. Um, we want to find from that position. So mid of, let's put the email for reference, email, mid of, which is substring thing, email. Now using instr, email, comma, at, we got the position of at. So we want after that, so +1, after that, the position. And then instr, email, there's no dot, you can say .com if you want to. Okay, so we don't want that position, right? So we say -1 from employee, from customer. Okay, it gets that. Okay, let's see. So this is starting from the character after that at to that .com thing. .com is in that character, right? So if I put dot, what happens? Oh, that many characters. Okay, this will not work then. So okay, so the total length. No, this email difficult, I guess. So you can get the total length of the email minus this, but you have to extract the characters. I think it's difficult, so let's leave it. We won't ask that. Okay. Uh, Let us assume that 4-digit area code is reflected in the mobile number. So you want the area code as a 4-digit code. So the phone number is, I think, in number here. So you want the first 4 digit, which is easy. Select, say phone, just for reference. Then left of, because we had phone as a character, so left of phone, comma 4 from customer. We'll just print the area code. Okay. Now, you want the phone number of the particular person, say at the address with at Rohini, for example. Select phone and the area code from customer where this is the cust add is the attribute name where cust add like. So you want the name Rohini to appear there. So Rohini. So Rohini could be anywhere within that address, so that should be fine. Just that person's phone number and area code. Okay. It's not the first four digits, it is the one eight, okay, second, third to six. Okay, so it is 1163. That's what we want. Okay. So mid or substring. From the third character, we want four characters. That will print 1163. From the third character, we want four characters. It is this thing. Okay, display emails after removing the domain name extension .com. So you want to trim the .com thing from the right. Select R trim email, four characters because it's always .com from customer. It's going to select star. Select star from customer. Okay, so what I want is to okay, trim, you cannot trim. Okay, there's no blank space, right? So yeah, the second argument is not allowed. Okay, the only way we can do that is this. So you want to print without the .com, right? Okay, let's do that. So without the .com, um, mid of email from position 1 to in str of email command .com and -1. I think that should print. So you want to take the substring starting from the first index to the, so in str of email comma .com will give you the index where the dot starts. And you want to go to the left of it up to just previous characters, so -1 in str of email comma .com -1. So that's one way. Otherwise, you can use a trim function as they say, but they didn't specify that earlier in this chapter, so I wouldn't. You can use it if you want to. Trim.com from email, so it will basically remove the .com thing. So select trim .com from email from customer. It's not that straightforward, and so that's why I didn't use it. But you can just get the substring from the index 1 to 1 character before the .com starts. Okay. Let's do the activity. List the day of birth for all employees whose salary is greater than 25,000. Okay. The date functions have not started, but we already started looking at them. So let's look at that. Display the date. So if you want just the year of birth of each employee, select M name. Say year of DOB from employee. You can get the year of birth. if you want to know what Monday, Tuesday, they were the birth date was, select M name, day name, this is the function name of day of birth, D of DOB from employee will give you that. So their birth date was on a Sunday, Monday, when and so on. Okay. Now, what we could also do is let's try to sort the employees by name, sorry, by date of birth based on that will be their age basically. So you can use the order by thing. Select, let's first order by year and then we'll go from there. Select employee name, DOB, just for reference, these things. Year of DOB from employee, order by year of DOB. So that will be 1975. Again, if you don't specify DESE, that will be default ascending order. So that's what it is printing. Now you want to order by say year, and then you want to go by month, and then within the month the day, right? So because you want to differentiate based on age. So you can do multiple order by. Let's remove this, we don't need it anymore. This is just for reference. So select EMP name, comma DOB. First order by year, then month of DOB, then day of DOB. So let's see the ordering here. So it's kind of unique years. So all years are unique, so that itself is sufficient. But if two people had the same year of birth, so let's try date of joining. So they had the same year of joining, so I differentiate based on that. So select EMP name, day of joining from employee, where, no, not where, order by year of joining, then month of joining, then day of joining. So it's based on their experience in the company, starting from the, I think it will go from who joined the earliest, okay? Right, so this person joined the earliest, then 2017, in January, this person joined on January 1st, and then this person joined on December 12th, and the day is also 12th. Okay, so this will be by from senior position to junior position. So this is how you can say order by year of date of joining, month and day, like that. So you can order by hierarchically, first the year, and then the month, and then the day, whatever order you choose it to be. Okay. Now you can also find the difference between the date of joining and date of birth by year and find the age. It won't be the exact age, but I'm just subtracting the 2 years and telling the age. So let's do that. Select start from employee. Okay, so select year of day of joining minus year of date of birth from, as I can say that as age from employee. That's the age. Now, if you want to list the employee name with it, we can do that. Okay. Now let's try something. Since we have labeled it as age, can we order by that age? Let's try that. Order by age. Yes, so that will work. So that's an advantage of labeling. So otherwise you have to enter probably the same operation again here. So select EMP name, comma, this difference in the years as age from employee. Then we can say order by the age. Okay. Then you can also use the limit function if you want to. So you can, if you want just the senior most person in the employee, you can limit one, then this should be the junior most. But if you order by age, this BESC, it will print in descending order, and then limit one, it will print just the first person. Okay. Let me come in a minute and pause the record. Okay, so let's continue recording. So if you want to list the top three people by age, you can also do like this, limit three, you can work like that. Now, let's do list the day of birth for the employees, the day of birth, which is the number, and whose salary is more than 25,000. Okay. All right. So select day of DOB from employee where salary is greater than 25,000. So this should print that. You can print the e-name if you want the employee name along with it. Okay, so these are the people who get more than 25,000. So how many of them totally? Let's see. Select star from employee. 7 people. So only one person gets less than 25,000. Okay. Okay. Now date functions, we were already doing it. Okay. Select the day, month, number, and year of joining of all employees. Year of joining. So select the day of DOJ and month of DOJ and the year of DOJ from employee. Okay. All right. Let's see. Okay. If the date of joining is not a Sunday, then display it in the following format. Wednesday, 26 November 1979. Okay. It's not a Sunday. Okay. Select day name in that case of DOJ. Day of DOJ. Then month name of DOJ, that's a November thing. Then the year of DOJ from employee where day name of DOJ is not equal to Sunday. Let's print the employee name as well. So for these people, the day name was not Sunday. So for the others, if you do it for everybody, select employee name, day name of DOJ from employer means for everyone, then Sanjuta, Mayank, and Sanjay joined on Sunday. So their name doesn't show up in the query. Okay. Okay, let's do now aggregate functions. So there's already one here. Find sum of sale price of the cars purchased by customer having ID from table sales. So let's go to say table sale. The CO1 person bought 2 cars. So what we want is find the sum of the sale price of these cars. Okay. So select sum. So that's an aggregating function of sale price from sale where cust ID equals C001. Okay. From the maximum minimum commission from the sale table. select max of commission and min of commission from sale. Okay, that's a maximum minimum commission. Okay. So we can get going. So some functions, aggregate functions do on only one row, where some will do on across the rows. And okay, so one thing we can do, start with a simple thing. Okay, so you can put count of star would return the number of records in a table. It will also return the number of records where the condition of the where clause is satisfied. If you put count of a column, it will print the number of values in a specified column, ignoring the null values. Okay, so let's do a couple. Select start from again say employee. So you want to find the number of salesmen. So let's say select count of designation, where designation equals salesman. It will, let's see, designation, right. Oh, we have to write the table name. Okay. So this is from employee. So select count of designation from employee, where designation equals salesman. It will print 5. Okay, that's the number of people with that thing. So that's a useful way to get a count. Now, if you want the okay, let's first do what is there. And we'll do the group by thing. Okay. Display the total number of records from table inventory having a model as VXI inventory. So select star from inventory. The VXI models, select count of model from inventory, where model equals VXI. That's 2. Okay. Display the total number of different types of models available from table inventory. Different types. Okay. We can do it like this. Okay. Select model name. You are grouping by count of model from inventory, group by from inventory, group by, yeah, it's group by model. So this is the attribute on which you're grouping by. So that's what you're printing here, and also calling aggregate function on that. So it should be fine. So it will print the model name and the count of that model from inventory group by model. Now, The group by also accompanies a having clause. So whatever the result that you're getting from here, you want to use of that and even filter this. So let's say you want to print only those models for which the count is more than one. So we can say select model comma count of model from inventory group by model having you can append to this query having clause something like this having count of model greater than one. So it will print only those models for which the count is greater than one. If you want count equal to one, it will print that also. It's up to you what you want. Okay. If you want, okay, that's one another thing you can do. So let's say select star from inventory again. So you want the just the number of models, but you want a distinct model. Okay. So select say distinct um, uh, model from inventory. Let's see. It will print only the distinct model names. Now you can get a count of that, count of distinct model from inventory. Will print the number of unique distinct models. Okay, this is good to know. Count of distinct model from inventory. So select star from, let's say, sale. So we can also get the number of unique customer IDs here if you want, or the number of cars, unique cars that have sold. Select distinct car ID from sale. So these are distinct from sale. So these are the unique cars that are sold. So 5 cars that are sold. So if you want, select car ID, count of car ID from sale, group by car ID. So it's going to print the number of cars that are sold in each model. Okay. Now let's say you want to find those customers who bought more than one car. Select customer ID from sale, group by customer ID, having count of customer ID greater than one. So these are the two people who bought more than one car, because if you select start from sale, you can see that information. C001 bought 2 cars. This guy C002 also bought 2 cars. Okay. Now you want to find the total income, the sale price based on each payment mode. Select sum of sale price from sale, group by payment mode. Now you can list the payment mode if you want. So from each payment mode, this is the amount. Okay, I had a typo here. Okay, let's fix that. So we can update this thing. That is I was 6, right? So let's do that. So select star from sale. Okay, so update sale, set payment, set payment mode equals bank this where invoice number is the primary key for this. So you have to make use of that equals I000 4 zeros and a 6. So select start from sale. So that's done. So now if you group by payment mode, it will print the total sales from each payment mode. Now, if you want to print the list list the maximum payment mode or maximum income payment mode. So select payment mode, comma, sum of sale price. Okay, so we can order by sum of sale price descending order limit 1. So that will print back things. So the group by will automatically group by payment mode. So the sum of sale price that you're processing here, when you say order by sum of sale price, it's going to take this sum of sale price. For that matter, you can also label this as sum of sales, something like that. Then you can order by sum of sales. I think it can be only one word. So sum underscore of underscore sales. This should be fine as well. Okay, if you don't put DAC, it will give you the lowest one, which is online. So online gave you the lowest income sum of sales, and the bank-based transaction gave you the largest value for the sum of sales. Okay. Let's say employee. Okay. Okay, let's see what else is there. Display the number of cars purchased by each customer. We already did it. Number of people in each category of payment mode. I think we did it. Let's do payment mode. Count of payment mode from sale. Order by. So we cannot say count or any aggregating function without saying grouping by. So we have to say group by payment. Okay, so you have to call the group by function because you're calling the group by thing, count on a particular attribute. That's a grouping thing. Okay, so you have to say group by explicitly. Okay, select start from sale. We read the sum of sale price by payment mode, yes, right? Okay, so let's say see the sale date. So I want to see the day name of sale date. From sale. So these are the days in which the 6 sales were made. So which day had the largest sales? So let's see, select day name of sale date from sale. You can say as day of sale from sale, order by day of sale, descending. This will be the Wednesday and so on. Okay. This is just in alphabetical order, nothing much, right? So order by will only sort alphabetically. We want to group by, so let's do this. We want to find the sales, total sales on each day. Select sum of sale price and day name of sale date from sale. So you see here, the aggregating function between the two is sum. And the day name is like Monday, Tuesday, and all these things, right? So it's not aggregating function from sale. Group by day name of sale date. So let's label it as an alias. We don't need to type the entire function again as day. So let me go over it in the top screen. Okay, select. What I want to select is the day name of sale date, sum of sale price from sale. So let's label this as day of sale, something like that. Group by day of sale. So it's going to print on each day. Thursday, this is the sale that was made. On Wednesday, this was the sale that was made. Friday, this was the total sum of sale price. Okay, so now this labeling you see here will also facilitate us to call group by on that as a column, basically, because it's treating this as a column now as day of sale. And you can now order by group by day of sale, order by day of sale now. That will now again in increasing order because I didn't say descending. So descending. So now it will print in descending order. Wednesday got the largest sale. Thursday and so on. Friday got the lowest sale. Okay, Wednesday got the middle of the week got the largest sale. And Friday got the lowest sale. Okay, so this kind of analysis can be made. And again, I think we did it. Let's do it one more time. Day name of sale date, count of, let's say just star, as a number of records matching that. As day of sale, you can label it like that if you want. From sale, group by day of sale, now having count of star greater than 1. So these are the 2 days in which more than one car was sold. The other days, just one car was sold. So let's print without having counting. Then it's going to print like this. Okay. All right. So the number of people in each category of payment mode. So that's something we can do. So select start from inventory, I think. No, that's how we can do something that here and then we go to that. Okay. So let's see, we didn't do much with fuel type. So let's print the number of cars with each fuel type. Select, let's say first the distinct fuel type values. So select distinct fuel type. So no parenthesis, just distinct space, the attribute name, fuel type from inventory. We'll print this. So if you want to get a count of this, if you want to get a count of this, one way is this without any confusion. Fuel type, comma, count of fuel type from inventory, group by fuel type. So 6 cars are petrol, 2 cars are CNG. So I'm grouping by fuel type. Um, let's try another thing. Select distinct. I don't think so. Let's get gone. I think that, let me see. Fuel type from inventory. No. Because a count is a grouping function expression, so it's aggregate function, so you cannot do this. So you have to go by this way. Okay. All right. So let's do something else. So let's find uh, the what do you call the average price of petrol cars and diesel cars, CNG cars. Select fuel type. That's again the attribute by which I'm going to group by. Then average price, average of price. So that's aggregating function. You can call it another attribute like price here. From inventory, group by fuel type. So going to give you the average price of petrol cars and average price of CNG cars. So it shows you that petrol cars will cost more than CNG cars, basically. Okay, on average. We can also find the minimum and maximum price of each fuel type. As well as the average if you want. Okay. This could be done. Okay, so you want to, we got already count. Okay. Now you can list the um, what is this? Car name. You can sort by car name if you want to. Select car name. So that's going to be the grouping by attribute. And average price of each car name from sale, from inventory, group by car name. So this is the average price of each car. So let's sort them as average price. So you can use this. Order by average price. Let's see, car name. Average, that is, didn't have space. So group by car name, space, order by average price. Now it's printing the increasing order. So let's descending order. So desired car cost more on average, eco car cost less on average. Okay, so this is something we can do. So always the grouping by attribute has to be the same that you have here listed without any aggregating function if you want to. And then the aggregation can be done based on any other attribute as well. Okay, so you can print for each car name, that's what you're grouping by, the average price, that's what basically it is. And you can label it as something like this, average price, so that you can use that label to order by anything like that. Now, you can also say, what are the car models whose average price is more than 60,000? So let's do separately. Select car name, average price as AVG price from inventory, group by car name, order by average price Let's do this first. Having average price greater than 60,000. 600,000, right? The 6 lakh. Okay, so only Baleno Desire cost more than 6 lakh. Okay. Now, can we order by after this or before this? Let's try. Order by average price. Descending order. Yes, we can do that. Okay. Let's see if we can do anything else. I didn't do the linking yet. We have to do that. Let's see the unique years of manufacture. Let's see distinct year manufacture. Inventory. These are years. Let's see the number of cars. Select, and for that you have to group. Select year manufacture as just say year, comma, count of, now we can say year, okay, count year from inventory, group by year. Okay, okay, that's something good to know. You can't say count of year in the field itself. You can use to group by, order by, and also, but not here. So you have to say count of star. So that will fix it. So cannot say the alias cannot be used as a field. Okay, you can use it as a field only here to group by and order by, not here. So we have to say count of star. Okay, so year and count of star, or you can say year manufacture, because that's the field name. Year manufacture is the field name. I can use that. That will work too. Okay, so it will print the year because that's where you're passing the alias, and then the count of your manufacturer will print like this. You can say as count if you want, as count, then it will print like that. Okay, now you can group by year, order by count if you want, you can do that. So it will increasing order, descending order. So 2017 had more cars, 2019 had fewer cars. Okay. So you can use the alias only to group by and order by and the having clause, but not anything else. So you can do the having, group by year, having count greater than one, order by this. So only these 2 years that count more than one. Okay. All right. So let's select start from employee. Okay. So let's do one thing. Let's select start from sale. So here you have the employee ID. So I want to print that person's name. So I want to print the invoice number and the name of the employee who made that invoice, who made that sale. So that's all it is. So select invoice number, comma, um, 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 you can do 2 ways. Let's try this one. Sale dot invoice number, comma, employee dot emp name from sale, comma, employee, where sale dot employee ID, sale dot emp ID equals employee equals employee.empid. Yes. So you have the table name dot the attribute name, comma, the table name dot attribute name from sale, comma, employee, where sale dot empid, okay, equals employee dot empid. So this empid will be compared with this empid here, and the corresponding emp name will be pulled up on the employee table. The corresponding invoice number will also be put up. So wherever the employee ID in the sale table is equal to the employee ID in the employee table, those records will be kind of put together here. Okay, so that's kind of joining. Okay, without explicitly using the join function. Later we'll see in your chapter the use of join, but here we are not using the join function explicitly, but you're really joining the two tables. Okay, then let's do something else. So we can join using the primary keys and the foreign keys. Okay. Let's do select star from employee. We did sale inventory where car ID is there. Select star from sale. Okay. So we want to now similarly print the car name with the invoice number. Select sale dot invoice number, comma, inventory, comma, car, dot, not comma, dot, inventory dot car name from sale, comma, inventory. Let's follow the order here. The sale table appears first. So I'll put that sale, then inventory, where sale dot car ID equals inventory dot car ID. Okay, so these are the car names associated with this. Now you can join multiple tables together if you want. Now, if you want employee dot emp name from sale, comma, inventory, comma, employee, where this is equal to this, and sale dot empid equals employee dot empid. So let's try, yes. So it will be matching the car ID in the sale table with the inventory table and matching the employee ID in the sale table with the employee table and pull out only those records corresponding to the invoice number, car name, and employee name. I'm joining here three tables literally. This is from the sale table, this is from the I think inventory table, and this is the employee table. There's one more table, I think the customer who bought it, we can do that as well. So select star from customer. And so let's get the customer name using the customer IDs because the sale table is linked to all these three tables, right? Okay, so select. So write fresh each time, you will get it easily. Don't try to use the history and type. Select. So let's print the invoice number from sale table. So select sale dot invoice number, comma, inventory, comma, car name, then employee dot emp name, and then customer dot cust name from sale, comma, inventory, comma, employee, comma, customer, where sale dot what was that we're using? Car ID equals inventory dot car ID. So linking the sale with each of them. Then sale dot emp ID equals employee dot emp ID and sale dot cust ID equals customer dot cust ID. So this is what it is. Okay. So these two people, Amit Saha and Renuma, bought two cars. Now you see that. and you can check, select start from sale, and so C001 is probably Amitsa High and Renuma is C002, and C003 and 4, just one cards from them. Okay. So this is the employee name, this is the customer name. So this is why you can easily link, join the two tables. Okay. The customer name, yeah. So this is an easy way of linking, joining two tables. Let's see how they have, what exercises they have in the book for this, for linking. Um, we'll use that as the uniform table later. Okay. Let's see, you can do anything else. Let's start from same. I'll do one last thing. Some employees sold more than one car, right? So select EMPID, comma, sum of sale price from sale. So this is the, when you once you use an aggregating function, in this case sum, you have to group by, no other way. So you have to have an attribute if you want. Now you don't have to. So if you do just say sum, that's fine as well, but you have to group by some attribute. So you better list that attribute value, right, also along with it, so you can clearly see what it means. So say employee ID is where is by your grouping by from sale, select employee ID, comma sale. So group, you have to group by employee ID now. So this is what did I think we did this. So and now you want to sort and all these things, right? And you can also say as sum of sale from, so we can say having sum of sale greater than say 600,000. Only these three employees made that, and then you can order by sale descending. Okay, so if you want to award someone for making more sales, you can give prize to this employee. Now, just the last twist. I want that employee's name. It is not in the sale table if you look at it, right? It's only the employee table. So we have grouped by this. So can we pull out the employee table name? Let's try. Not sure. So EMP, sorry, employee.emp name. Okay. From sale, comma, employee, where now once you join two tables, you have to distinguish the column names. So this EMPID comes from sale.empid. This sale price also comes from sale.sale price. As sum of sale is fine from sale, comma, employee, where sale.empid equals employee dot That's you're joining employee.empid group by sale.empid. So you have to distinguish each attribute by the table name. Having some of, I think this should be fine. Okay. So I got the employee name as well. So select sale.empid, employee.emp name. So I got the corresponding employee's name. So Mayank basically made the largest amount of sale. So you attribute that with the table name, it should be fine, comma, sum of sale price. And you're labeling it as sum of sales, you can use the grouping thing. From the table names sale and employee. So once you join, differentiate each attribute along with the table name. So where sale.employee ID equal to employee.empd, that's the way of joining and getting the records. Group by sale.empid, having sum of sale greater than 60,000, 600,000, order by sum of sale in descending order. Very good. Okay, so let's do like this one more if possible. Select star from inventory. We can probably do the same thing for select star from sale. The let's see. The car name if you want that was sold more or the model. Okay, car name and model also could be filled out. Okay, let's do that and probably stop. So I want to print the total sale price for all car names and the corresponding model. So that's based on car ID, right? So select sale.car ID. So that's what you're kind of going to group by, because each car ID has a corresponding car name and model name, right? Excuse me, comma, sum of sale price as sum of sale, that's just an alias. Now this sale price is coming from sale as well. Now we want the car name and model from the inventory table, inventory dot car name, comma, inventory dot model name, that's just the model. Sum of sale or sale price from sale, comma, inventory, where sale dot car ID, you're joining first, equals inventory dot car ID, group by sale dot car ID. I think that's just print that. Okay, so this is the sum of sale of each car name and the model, basically. Okay. If you want, you can get a count of that. Let's see. Count of sale.car ID will do as count. You can leave it as count. This is the count. So 6 cars are there in the inventory, but 2 of them are the S0002 model. Okay, now because you can check back in the table here. All right, only S002 we have 2 entries, others in the inventory have only 1 entry. Okay, so automatically that will be more. So now you can sort and do all these things. So this is, you see how easily you can join two tables. Okay. Um, so order by sum of sale, descending order. Okay. And you can also filter having, I think having could go this way, having sum of sale greater than 600,000. No. Okay, so that's something you have to know. So the having has to accompany, let me do it this way. So that's something you get to know. So the having has to accompany the group by. You cannot separate group by and having with some other condition like order by. So let's do it this way. So you have to have having sum of sale greater than 600,000, and then you can have order by. Okay, so group by, that's right. So you want to now print only those having sum of sale greater than 600,000. So immediately after the group by, if you want to use having, you have to use it immediately after the group by, not somewhere later. So having sum of sale greater than 600,000. Now you can order by sum of sale of sale in descending order. So this will print in descending order greater than 60,000. Okay, so if you use having, it has to immediately follow the group by. Okay, so let's stop with this.